Let's take a look at 14. If you downloaded the initial PDF that I posted on WebAssign with these problems, you might have x to the third up in the top. I changed it because I wanted to make sure this one worked with partial fractions. So I changed it to be x squared plus 4x plus 7 over x plus 1 times x squared plus 1. We're going to use partial fraction decomposition to evaluate this function. We're going to split it up into a couple different pieces. We've already got the denominator factored. Okay, if you looked at the solutions yet for number 13, you can see that you need to factor that first before you can figure out what those partial fractions are. We've got it factored already. X plus 1 is a linear term. X squared plus 1 is an irreducible quadratic. So when we go to set up the partial fractions, we're going to take a over x plus 1 plus bx plus c over x squared plus 1. Whenever we have an irreducible quadratic function, whenever we have an irreducible quadratic factor, that piece of the partial fraction decomposition is going to have a linear term in the top. So if we use just plain old common denominators to put these guys back together, I'm going to have a times x squared plus 1. I'm going to have bx plus c times x plus 1 on the side. Cleaning that all up, my numerator becomes ax squared plus a plus bx squared plus bx plus cx plus c, all over x plus 1 times x squared plus 1. We want that new numerator with a, b's, and c's in it to match up with what we've got in our original numerator of x squared plus 4x plus 7. We're going to set up a system of linear equations in order to do that. I need my x squared terms to add up to 1. I need my x terms to add up to 4. And I need my constant terms to add up to 7. My x squared terms, I've got an a and a b, so a plus b equals 1. My x terms, I've got a b and a c, so those add up to 4. My constant terms, I have an a and a c, those add up to 7. Again, the 1, the 4, and the 7 are coming here from that numerator of what we originally started with. You can solve that system of equations quickly on your Inspire. It'll give you a equals 2, b equals minus 1, and c equals 5. Now that we've got those, we can go ahead and work with the integral. So the integral of x squared plus 4x plus 7 over x plus 1 times x squared plus 1, we can split up into two pieces. The two pieces are going to be 2 over x plus 1 and negative x plus 5 over x squared plus 1. I'm going to take that one step further, and I'm going to actually split it up into 3 pieces. I'm going to take that second fraction and write it as x over x squared plus 1 and 5 over x squared plus 1. So that way I've got a little bit less to work with in my numerator. So the first antiderivative, 2 over x plus 1, is going to be 2 times the natural log of x plus 1. We can again write these up as 3 separate integrals if you want, just to kind of work with them. The first one, like I mentioned, it's going to be 2 times the natural log of x plus 1. The last one over there on the end, it again has that kind of, oh, this is reminiscent of the arctan function. It becomes even more so. It looks even more like the arctan function if you pull that 5 out. Okay, that's all I did on this from here to here is that 5 came out. So here's what I'm working with now. 1 over x squared plus 1 dx. That's exactly the same thing as 1 over 1 plus x squared. So this one right here is for sure the arctan function here, arctan x. So that one's good. This one we're good with. Whenever we have a linear function in the bottom like that, if you want, you can pull the 2 out, but it's just going to be the antiderivative is going to be the natural log. The one in the middle is a little bit trickier. I didn't write this all out, but what you can do for the one in the middle is let u equal x squared plus 1. If you let u equal x squared plus 1, then du is going to be 2x dx. Make a substitution there. You're going to have a half out in front of your integral, and then it's basically just going to be du over u. That has an antiderivative of natural log. So what we end up with is 2 times the natural log of x plus 1 minus a half times the natural log of x squared plus 1 plus 5 times the arctan of x plus c. Again, if you missed it, take a minute, look at that middle integral. It can be evaluated using a u substitution with u equals x squared plus 1 and du equals 2x dx. But that's our final answer for this one. This is the type of problem you may end up seeing something different when you do this in your calculator. If I had to guess, it would probably put those 2 natural logs together using properties of natural logs. but what we've got here works just fine.